Good evening, Professor Sills here, and I hope the wind noise isn't too bad. I'm sitting out here in the great wide open in Cortez, Colorado, which is probably best known for being just a few miles away from Mesa Verde National Park, where I'm planning on going tomorrow morning. Now, what I want to do is spend a little bit of time with you and do a little enrichment with the image you see behind me. But first thing I want to talk about philosophy and the course a little bit. You've been spending time looking at tropical cyclones, and this is turning out to be a really quiet tropical cyclone season. We're past the peak. We'll see what happens from there. By the way, you're within 2, maybe 3 weeks at the most of a exam, so be prepared for that. It's going to be at the end of Unit 1. And, students often come to me and they kind of wonder, well, what's with my philosophies? Where are they coming from? First of all, you're adults, and I want to treat you as adults. If I give you an assignment to do, then the purpose of a due date is to let you pace yourself so that you don't end up with 4,000 things to do 3 days before the next exam. I also post debriefings to every assignment, so the goal is for you to compare your work to my answers and my solutions, if you will, and make sure that you understand a self-check on what it is you're doing and make sure you understand what it is that I'm asking of you. If you do all those things, and if you're on track with me, if you're like, okay, question 1, I get it, I understand what he's asking, I understand what I answered, and I understand what he's saying. And then question 2, same thing. Question 5, same thing. Whatever it is, you're on track to success. There's no reason that you can't earn an A or at worst a B in this course. Now, what do I find historically? I find that there are a lot of students that get A's and B's, and there are students that fail. Well, the students that are at the other end of the spectrum, the ones that get D's and F's, are the ones that aren't doing the work. They're either kidding themselves, or they just know they're not doing it, and they hope they're going to slide by. I don't know what they're thinking, but they hope they're going to slide by. If you're somebody who's doing all the work, if you're putting the time in, and if you're checking your work versus mine, and if there are issues that come up that you're not sure of, you ask me, you should be fine. I'm in that system every day or every other day at the worst, and so if you post something, I'm going to get back to you. Now, that said, we're in a change of seasons. We're going to be looking at seasons and the causes for seasons very soon, but suffice to say, I think most of you have some understanding of what the seasons are about. I mean, you've been around on the planet for a number of years. So let me take a second. Let me show you something kind of advanced. I will give you a link for this. This is National Center for Environmental Prediction website, National Weather Service, if you will. And what this is a computer model. When you watch the evening news, if you hear them mentioning the computer models, or they talk about a track of a hurricane, and their computer models are forecasting, this is that. So what this does is this goes 384 hours into the future. 384 hours. What is that in human speak? Well, a day is 24 hours. 10 days would be 240 hours. So 384 hours would be something on the order of about 15 days. So it's about a 2-week forecast. Now, why don't you hear 2-week forecasts on the radio? Well, first of all, nobody really wants to hear that. They're good with 5 days. The second thing is, much beyond 3 days, the forecast accuracy goes straight down. In fact, if the weather gets dynamic, there's a storm headed up the coast, or there's, some other kind of dynamic weather event that's about to occur, generally, you're not going to get accurate weather forecasts much more than 2 or 3 days out. One of the things that fascinated me as a child was, a storm is headed into New Jersey in the winter. Will it rain or will it snow? And there's all the difference in the world. Of course, as a kid, all I cared about is, are we going to get a snow day? But the reality is, the rain-snow line always seems to land somewhere in Passaic County. And the question is, where is that rain-snow line going to fall? And I know it's only the 2nd of October, so it's way too early to be thinking about that, or is it? There's actually going to be a storm that will impact, and I'll show you this, a few days from now in the upper Midwest, where the most likely form of precipitation will be snow. And it's early for that. It's very early for that. And that's not an indicator of what the winter is going to be like, and it's not an indicator one way or the other of global warming or global cooling or anything. That's another issue. Be careful about what you believe. When it comes to global warming and global cooling, I can remember in 1975 Time magazine showing a iceberg on their cover and saying, we're in global cooling. And now all of a sudden, the politically correct thing to say is we're in global warming. Well, the reality is there is evidence of what the Earth is doing, and as a matter of fact, in the last 15 years, there's been no temperature change. It's not warming, it's not cooling. So go figure. You can draw your own conclusions from that one. But always remember, global warming and global cooling is a scientific issue, not a social issue. So let me get on to the science here and show you something interesting. You're looking at a very advanced weather map, and I'm going to explain this, and it's, if you get it, you get it. If you don't, you don't. But I want you to at least have the opportunity to see this. This is a computer model called the GFS, and it's one of our most accurate computer models. You can see up here, it's showing you that this is from October 2nd at 1200 Universal Time or Greenwich Mean Time. The way to look at that is 4 hours ahead of New Jersey. So 1200 GMT, Greenwich Mean Time, would be an 8 a.m. map, forecasted 6 hours into the future, which makes it valid for Tuesday, which is today, at 2 o'clock in the afternoon, or 1800, which would be 1400 in New Jersey. Just subtract 4 hours from these universal times that you see here. Excuse me. So, as we look at this, there's some information on this map. You see the H's and L's. You see L's right here. You see H's right here. These represent high-pressure and low-pressure systems. The elementary school view of the world is a high-pressure system would represent fair weather, and a low-pressure system represents stormy weather. I say elementary school because there's a little more to the story than that, and we'll learn that as we go through the semester. You see here a low-pressure system centered in Kentucky. Start learning your geography. And you can see green and blue to the east of it. That represents precipitation, not necessarily falling at that moment, but precipitation that has fallen in the previous 6 hours. That's how these work. Here you see a low-pressure system, also known as a cyclone, in southern, let's see, that's Ontario. That would be Manitoba. Saskatchewan, Alberta. Yeah, you can double check me on my geography, but that would be Manitoba, southern Manitoba. And this one looks like it's well defined. It's got isobars circling around it. ISO, excuse me, ISO for equal, bar for barometric pressure. It's a mapping thing. So this shows us that it's a well-developed low-pressure system. Here we've got a high on the west coast of Canada, and here we've got a high up in the Yukon. This would be polar air, representing cold air. And we can infer temperature from this map because these blue lines and red lines represent thickness between two layers in the atmosphere. Here's the thought behind that. If you have a balloon and you warm the air in the balloon before it pops, what will the balloon do? Answer, it will expand. If you cool the air in the balloon, it will contract. So would it be fair to say that cold air is denser, it's more compact, and warm air is less dense, it's less compact? Meteorologists measure the distance between two layers in the atmosphere and call that thickness. Makes sense, right? Distance between two layers should be measured as thickness. Now, follow my train of thought. The warmer the air is, the more the air will expand. That means the thicker the air is between those two layers. The colder the air is, the less thick the air is. Make sense? So when we look at these numbers, these represent thickness in decameters, tens of meters. And to get technical, between the 500 and 1,000 millibar pressure levels. Don't even worry about that. What this is really showing you is the lower the numbers, which are generally further north, the colder the air. The higher the numbers, generally further south, and they go in 6 decameter increments. 540, 546, 552, 558, 564, 570. The higher the numbers, the warmer the air. The reason that everything from 540 and smaller in thickness is in blue is because those thicknesses are generally low enough that if precipitation is falling, doesn't mean precipitation has to fall. You've seen plenty of cold weather in New Jersey with no snow. If precipitation is falling, it is probably cold enough to snow. If the thickness is over 540, it is probably not cold enough to snow. In other words, it will fall as rain. This is one of the things that meteorologists look at to determine when there's going to be a storm. Will it snow or will it rain? You can see, for example, the precipitation that fell here fell with thicknesses of 570, 576, 564, way, way too warm for any snow. Not a great surprise considering we're at the beginning of October. That's not a surprise. Now, I am currently here, and I'm on my way probably up here. Well, that's one thing I'm looking at, because I'm looking at these thicknesses up here, and you see me sitting in a t-shirt outside. It's almost sunset, so I'm concerned, not concerned, but I have to be aware of when the weather changes and we move from a summer-like pattern, which we're in, into a late fall or winter pattern where I'm not going to be wearing short-sleeve shirts or sitting outside making videos, okay? You in New Jersey are going to be undergoing the same kinds of change. There are changes that are occurring to the trees right now. You're going to see them to become more apparent during the month of October, which is generally the month where you'll see peak color in New Jersey towards the end of the month. Now, if we toggle through this, I want to point out a couple of things. Watch the 540 line. Watch what it does, and you can see where the cold air is encroaching. And again, my computer is maybe behaving a little bit slow. It's going to go in 3-hour increments here. So it just adjusted. We're now 12 hours, 15 hours into the future. And what I see here as I look at this is a packing of the thickness lines from southern Alberta through north central Wyoming. And again, take time, look at the map, you can see where these places are. North of this blue line in Montana, northern Montana and southern Alberta, this could very well be falling as snow as a result of this storm system, which is causing the precipitation. North of it is a polar high-pressure system, which is cold air. So the days in British Columbia and in Alberta are probably at this point getting quite chilly, highs in the 40s, maybe the low 50s, with overnight lows in the 20s. Down here, not so much. Our days are around 80 degrees. In New Jersey, I know you're soggy right now and kind of humid, and your days are fairly mild too for this time of year. So let's go a little further into the future. And there's nothing really exciting on the edge. You're going to see me bring this up when we get further into the season, and there's something spectacular that I want to share. But you may notice that that 540 line is now diving south through Montana and has reached the Wyoming border and is now south of Wyoming, south of the Wyoming border, Wyoming-Montana border. It's into the middle of South Dakota. And again, you might want to look at a map of the U.S. and see where these places are. The 540 line now stretches right across Wyoming and South Dakota. And clearly, there's some pretty chilly air which has invaded the Dakotas, North Dakota, South Dakota, and Montana, but has not really made it into at least most of Colorado. There's still a 564 running through south central Colorado, and again, I'm here and I'm headed there, so I know that my daytime highs are not going to get all that chilly yet. And I'm looking now a couple of days down the road. This is October 4. As I continue doing this, I could do this all the way through. I can track what's going on. I'll do this a little faster so we're not making this into a 20 or 30-minute video. We're already at 14 minutes, so I don't want to take too much of your time. But you can see that this polar air is beginning to invade into the upper Midwest, where you see the conditions, the thickness is under 540 throughout all of Minnesota. And as I move further into this, I'm now approaching Friday morning. I'm into Friday morning. And I can see that there is moisture beginning to line up in the Midwest and work its way into Ohio and some over Lake Michigan. And the northern stretch of this moisture, like over Lake Michigan itself, is clearly north of that 540 line. So what are we going to talk about? We're going to talk about snow falling in western Michigan and eastern Wisconsin, probably by Saturday morning. All right, sometime on Saturday. And again, the further we get out into the future, the less reliable forecasting is. But you can see the cold air clearly over the upper Midwest. And you can see a gradual progression. And what you will see if you yourself go to this link is a retreat of the cold air. You can see now that the 540 thickness is actually into western New York and northern New England. So there's a chance that northernmost New England in this next storm, which looks like it'll be off the coast, if this is accurate, and I'm now looking out 120 hours, which is a solid 5 days, takes me to Sunday morning at 8 a.m. It's possible that snow could be falling in northern New England Sunday morning and even in west central New York and maybe in northwestern Pennsylvania, not in New Jersey. New Jersey will be getting another soaking rain, it looks like, going into Sunday morning and probably ending by Sunday morning. So, with that, I'm going to end and simply encourage you, if you want, you can go to this link that I'm going to give you. The model that I used here is the GFS, and it's run 4 times a day. It's run at 0Z, which would be 0 Greenwich Mean Time, or 8 p.m. It's run at 6Z, which is 2 a.m. It's run at 12Z, which is 8 a.m., and it's run at 18Z, which is 2 p.m. When we go off of daylight time, and that's going to be, well, it's usually Halloween weekend. I think Congress changed it into sometime in the middle of November. But whenever we do that, whenever we go off daylight time, back everything up an hour. So instead of 8 a.m. and 2 p.m. and 8 p.m. and 2 a.m., it's going to be 7 a.m., 1 p.m., 7 p.m., 1 a.m. That's when these times will represent. Greenwich Mean Time doesn't change. Anyway, you take care and reach out to me if you have questions.